My name is Connor, and I'm a data scientist at Predibase, the low-code declarative machine learning platform. Today I'll be walking you through an end-to-end use case for molecular biology named entity recognition. We'll be covering a few key user stories, including connecting data, training models, deploying models, and querying those models using PQL. Let's start by connecting our data. Predibase makes connecting data fast and easy with only a few clicks. You can connect structured data from sources like Snowflake and BigQuery. You can also connect to object storages such as S3, ADLS, and GCS. Let's take a look at the dataset we're using today. In this dataset, we have two columns, a sentence column and a tags column. In each row, we have a sentence and a corresponding set of tags that indicate the entity type for each token in the sentence. The possible values are DNA, RNA, protein, cell line, cell type, or other. Because every token has a corresponding tag, the sentence length and the tag's sequence length will always be equal. The goal of this prediction task is to train a model that can take an input sentence and produce a list of tags that can be used to provide contextual information, such as entity tagging and definitions to complex molecular biology corpuses. Now that we've seen the data, let's go train our model. This is our model repository for this project. Here you can collaboratively train, version, and iterate on our models until we reach production-ready performance. To train a baseline model, we need to first select our dataset and our target. Next, there are a few specific parameters we need to set given the nature of our prediction task. Because we have a text input and a sequence of tokens as an output, we want to use an RNN for our encoder here. Since our text tokens are separated by spaces, we need to set the tokenizer to space. Next, we're going to set the sample ratio to 0.1. This tells Ludwig to train this model on 10% of the data. This is a good idea for our first model to make sure that things are running smoothly before we commit to training on the entire large dataset. For the output feature, we need to select the tagger decoder. Lastly, we need to set reduce output to null. This will allow the model to generate a prediction for each token in the input sentence. Now that we've set up our model config, we can click Train to start the model training process. However, since the model training can take a while, let's skip ahead. It looks like our model is receiving about 87% accuracy. This is pretty good for a baseline model, but let's see if we can make it even better. To create a new model, using this model as a template, we can click the New Model button in the top right-hand corner and select New Model from number 1. Here, the same parameters from the first model are already set, but this time I'm going to set a few additional parameters to improve the model. First, I want to set the cell type to LSTM. This is because LSTMs tend to receive better performance on sequence-to-sequence prediction tasks. Next, I'm going to set bidirectional equal to true. Bidirectional RNNs have also been shown to have performance benefits in these sorts of modeling tasks. Now let's train our second model. Looks like our model got nearly 93% token accuracy. That's pretty good. If we're happy with our model, all we need to do in order to deploy to production is click the Deploy button in the top right. This will spin up a Predibase managed deployment with a corresponding endpoint that you can use to query the model. Another way that we can query this model is using PQL. In this query, we are telling PQL to use version 2 of our molecular biology NER model to generate tags for the input sentence we pass on line 5. As you can see in the outputs below, the model has produced the corresponding set of tags using pql. You can even pass in a whole batch of sentences and use your model to generate tags for them all at once. A model like this could hypothetically be used with some front-end tooling to create dynamic highlighting to help define and identify different entities within molecular biology text bodies. Today we've seen an end-to-end example of how easy it is to create an entity tagging model for a complex knowledge domain using Predibase. If you're interested in exploring more, feel free to reach out and request a demo.